We want to find all integer solutions to the equation 6x squared minus 2xy plus 7x minus y equal to 5. Okay, in the form xy where x and y are all integers. A. Justify that for integer solutions x divides y plus 5. Hence, otherwise deduce that for all k in the set of integers we have y is equal to kx minus 5. Okay, so I'm going to go to my original expression, right, and I try to play around with it. So having that 6x squared minus 2xy plus 7x minus y is equal to 5. When I come to my proof, I see y plus 5, so I have to send this y to the right hand side. All right, so doing that, I'm going to have 6x squared minus 2xy plus 7x is equal to y plus 5. Now from there, on the left hand side, x is common. All right, and if x is common, if I factorize x, I'll be left with 6x minus 2y plus 7 is equal to y plus 5. Now I'm going to divide both sides, or let me say anyways, I'm going to divide both sides by x, and I'm going to have 6x minus 2y plus 7 is equal to y plus 5 divided by x. So since we know that since x and y are all integers, okay, we're taught in the equation that x and y are integers. Since x and y are integers, then we have that clearly 6x minus 2y plus 7 will also be an integer. Okay, and since 6x minus 2y plus 7 is an integer, it therefore means that the right hand side, which is just the equivalence of what we have, so the right hand side, which is y plus 5 divided by x, will also be an integer. All right, and for this to be an integer, it therefore means that our x must clearly divide y plus 5. All right, because if x is not able to divide a y plus 5, then that is not going to be an integer. So x must divide y plus 5. So we have proven the first part of the equation. Now after doing that, we have to deduce that for all k in the set of integers, y is equal to kx minus 5. So we just go directly from this statement, which says that x divides y plus 5. Now x divides y plus 5 means that there exists an integer k, such that we have that our y plus 5 must be equal to k times x. So if we find x, we are going to have, sorry, if we find y will give us kx minus 5. So we have proven. Alright, let's go to the next part of the equation. By using a above, show that k is equal to this. So I'll basically replace my y here with the value of kx minus 5, then I'll make k the subject of the formula. Alright, so if I do that, I'm going to have that, okay, my 6x, I'm going to have that this right hand side, y plus 5 divided by sorry, excuse me, y plus 5 divided by x, like we said, it is equal to this quantity. All right, but now we clearly see that y plus 5 divided by x is just equal to an integer, which is k. So my left hand side will be replaced by k. We replace the left hand side with k. Now the right hand side, we have 6x minus 2 into what is y, kx minus 5, then plus 7. Now from here, I'll just expand and make k the subject of the formula. So I have k equal to 6x minus 2kx plus 10, then plus 7. Yes, plus 10 plus 7, and 10 plus 7 is 17. So I'm going to add 2kx on both sides. Okay, I'm going to have k plus 2kx equal to 6x plus 17. So in a nutshell, I'll factorize k on the left hand side, and we have k into 1 plus 2x, okay, or 2x plus 1 equal to 6x plus 17, equal to 6x plus 17. So at the end of the day, what is k? K is going to give us 6x plus 17 divided by 2x plus 1. We have proven that that is k. Alright, now the next part of the equation, solve for all integers. Solve for all integer values of x and k using b above. So we first of all need to find x, alright, because we know that k is an integer. So when we arrive at something like this, we have to do long division, alright. So we have to do long division. So it's very long to do long division when I'm typing, so I'll just do my long division on a piece of paper with me, then I'll just write the answer, but I believe you can do long division. So we have 6x plus 17 divided by 2x plus 1, where we have 3. We have 6x plus 3, subtract, we have here 14. So when you do long division, you realize that k will be equal to, the quotient is 3, the remainder is 14, and the divisor is 2x plus 1. I think if we expand back, we are going to have here 6x plus 3. Yes, this is what we have. Now since we know that k is an integer, okay, we know that k is an integer, it therefore means that 3 plus 14 divided by 2x plus 1 is also an integer. Now it is an integer if and only if, so we need to give the condition for it to be an integer. For this to be an integer, we need that this second portion here has to be an integer, because the first portion, which is 3, is already an integer. Alright, so we just need that this second portion has to be an integer, Now that second portion is an integer provided your 2x plus 1 divides 14. In other words, we are trying to say that our 14 is just equal to a multiple of 2x plus 1, and 2x plus 1, maybe the multiple is p. Alright, so that if you replace back the 14 here with 2x plus 1 times p, and we divide by 2x plus 1, the 2x plus 1 cancel, and we have p, which is an integer. So p here is an integer. Okay, so from here I know that 14, so I'm just going to say 2x plus 1 times p will be equal to, now 14 can be written as plus or minus 1 times plus or minus 14, okay, or it can be written as plus or minus 2 times plus or minus 7, and vice versa. Alright, or we can also have plus or minus 14 times plus or minus 1, or we have plus or minus 7 times plus or minus 2. So at the end of the day, we are just going to have something like 2x plus 1 will be equal to either plus or minus 1, plus or minus 2, plus or minus 7, or plus or minus 14. So what you're going to do is that you are going to equate 2x plus 1 to be equal to plus or minus 1. You solve for the value of x, you're going to have two values of x. You equate it to plus or minus 2, you have two values of x. Equate it to plus or minus 7, you have two values of x. And equate it to plus or minus 14 and solve and have two values of x. Then to have the values of k, we now come back here and you replace this man. Alright, you replace your x with all those values, you have all your values of k. Alright, and then now automatically you have all your values of y, because we know that our y, where is it, we know that our y is equal to kx minus 5. So when you replace the value of x and the corresponding value of k, you find the value of y, and you're done with the equation.